So hi everyone, today in this tutorial we will be running through how you can fine-tune modern BERT, which is a recent advancement of traditional BERT model for classification problem. So in this particular tutorial we will be trying out multi-class classification over a dummy dataset. So let's get started. If you are new to modern BERT, you don't know how it is better than BERT, I have already covered its technical details in the previous video. You can check that out. So to get started off, we first need to pip install Torch 2.5.0, Torch Vision Point 20.0, setup tools less than 71.0.0, scikit-learn. Then you need to upgrade datasets, accelerate HF transfer as well. And then you need to pip install this particular Git repo, that is transformer, with a specific commit ID. As you can see, I will be sharing all the code, so you don't need to worry about. As you can see, I am using Google Colab for now. Now in the next snippet we will be loading a text classification dataset, as you can see from the dataset ID, that is again coming from Hugging Face. Now if you look here, this is the dataset that we have got. This is a text. In this discussion thread, we delve into the effects of urban sprawl on community structure, the latest quarterly report from XYZ Corp, etc. etc. And these are the labels associated with them. So basically, it's a theme classification. Given the text, what theme it follows. I'll be showing you the different labels also, and not just the ID. Next up, you need to load the model ModernBERT-base and then load its tokenizer as well. I hope you already know how a tokenizer works with the transformer model that we are loading, ModernBERT base. Now if you look here, basically we are doing some sort of a pre-processing, changing the name of the columns so that it becomes compatible with the tokenizer, the trainer object that we will create. Next up, as you can see here, we are doing something special here. What we are trying to achieve, as I already showed you in the data set, there are IDs for the label but not the names. So we are trying to create two dictionaries for mapping ID to label name and label to ID. So that would help us in the entire process. So this is the different labels that are present in the data set: business and industrial, book and literature, beauty and fitness, auto and vehicles, people and society, sports, shopping, etc. And in total there are 26 labels. Once done, the rest of the part is quite easy. If you have already fine-tuned some models from transformer, you need to provide your training arguments, output directory where the model would go, training batch size, number of epochs, learning rate. As you can see, number of train epochs is 1. Why I'm doing so? Because I'm just trying to demonstrate the code, not the entire process. You can increase the number and then try out the actual performance. We have activated the bfloat 16 as well. Optimizer is AdamW torch fused. Logging strategy steps. So basically now the logging steps, how to log in, how to show you the results, etc. Now we'll start training the model, providing a training data set and evaluation data set. So in the first step, you might have seen we have splitted the data set. So there is the test data set coming from. Now here you can see that I ran it for just one epoch. So results are not great. Don't expect to be the best. I'm just trying to complete the entire loop. Here you can see that the training loss is 0.26. You get a train loss here as well. Epoch is 1. Different information is present. Validation loss is 0.33. Once done, we will try to now use the particular trained model to inferencing. So basically I will try to predict over the test dataset, as you can see here. Now once the test dataset is predicted, it will give you a number of probabilities for all the different labels. So we would be getting the maximum probability np.argmax for each of the arrays. So if the, for example in the test dataset, the tokenized dataset test, you have 20 samples, so the output would be 20 into 26, because if you remember we have 26 labels, so it would be outputting the predictions for all the 26 labels. Now we would be extracting the maximum value present in the particular array for a given label, for a given entry. Hence you would get the maximum probability entity, and then we will use the dictionary that we created, id to label. So basically taking the index of the particular label whose value is the highest, we are now mapping it back to the label name. And then I will be showing you the example text also. For what input, what was the label. Here you can see that predicted label was beauty and fitness and actual was business and industrial. No worries, because as I already told you, the pops are quite less, batch size is very small, and these are the results. But if you train it for longer, I think the results should improve. These are all the predicted labels that we got for the entire data set, the test data set, and hence you can now inference out. So this is how you can use ModernBERT for a text classification problem. You can fine tune it quite easily, as you can see from transformers, and the model is quite amazing, as I've already showed talking about its technical details in the previous video. I will suggest you to go back to it, have understanding, and then try out fine tuning it for your use case as well. Thank you so much.